Good morning, everybody. This is an emergency live briefing as we have an enhanced risk in place across northern Iowa, far southern Minnesota, southwestern Wisconsin, including northwestern Illinois as well. And this enhanced risk is mainly for a very large hail threat, also a significant wind threat as well, as these storms are going to congeal into a complex of storms that eventually is going to pass into northwestern Illinois and southwestern Wisconsin a little bit earlier. And I think that this event still has some question marks as to how it's going to play out. I was looking at the latest RAP model, and it does look like there is largely some veered winds in Iowa, some anticyclonic curvature aloft. It is also incredibly hot out there as well, some higher base storms, but dew points are juicy across northern Iowa. They are forecast to lift up to near 70 degrees as we go through the late afternoon into the evening hours. And there is a chance of a meso-low that should propagate up that surface boundary, passing along the Iowa-Minnesota border by mid to late afternoon. And the timing of that low is going to be critical because just ahead of it, there is sufficiently southerly winds at the low levels to generate wind shear for a tornado threat. But if that low ejects a little bit too fast in its wake, those surface winds are largely going to be due westerly, and that's a little bit less favorable for a tornado threat. Either way, though, I still see a substantial threat for very large hail and damaging winds. This is the latest RAP meso analysis forecasting out this through 6 hours, through about 20Z, and we can get a good idea of what's going to be happening here with that surface boundary. This morning, that surface low is near the intersection of Minnesota, South Dakota, and Iowa, and it is forecast to propagate northeastward along that boundary through southern Minnesota. And you can see that the instability axis is building up through the Missouri River Valley, up through eastern Nebraska, western Iowa. That's why I wasn't too concerned with that complex of storms evolving through southwestern Iowa, moving due south, and then eventually into northern Missouri. And that's because this instability is building in from the west. But still, there are a lot of uncertainties. There is this high pressure back behind, some northerlies. There's that boundary as well, some anticyclonic curvature aloft to the upper levels that we're going to check out. But look at how that instability builds across southern Minnesota. Notice how those surface winds are more out of a due southerly direction there. This is at 20 Z's though, so that's about 2 p.m. Central Time. And that low is forecast to eject into southeastern Minnesota there by about 3 to 4 p.m. And notice that convective inhibition that's in place across southwestern Wisconsin, southeastern Minnesota, northeastern Iowa. There is a chance that that the most favorable low-level shear is going to overlap with that convective inhibition ahead of that surface low. And there's still a lot of uncertainty as to whether it's going to destabilize ahead of that surface low as well. Also associated with that subtle perturbation are these southwesterly 850 winds at about 20 to 35 knots, increasing as you go down into northern Iowa there with time. And notice how a majority of that favorable 0 to 1 kilometer storm relative helicity is located also in the path of that surface low. But there is a chance that that favorable low-level shear is going to eject rapidly northeast across southeastern Minnesota into southwestern Wisconsin with time. And that's where that greatest tornado threat is going to be, is likely going to materialize later on today. Let's take a look at some of these latest models here. We'll have to reload pivotalweather.com website. We're going to start with the 3-kilometer NAM. The HRRR dry bias is definitely an issue, basically at all times, but you can see kind of this dying MCS that's across southern Iowa. Now it's just largely some stratiform rain and anvil debris down there across southern Iowa, but that instability is building in from the southwest, from eastern Nebraska into western Iowa, punching into northern Iowa and far southern Minnesota. This is the 12Z 3-kilometer NAM here. Spam call coming in hot there. We will decline spam. We decline spam here at Team Dominator headquarters. So here is the 3-kilometer NAM, and I believe this is one of the more trusted models here. Notice how it peters out that complex of storms across southern Iowa. It's basically a nothing burger. There likely will be an outflow boundary left behind. Should lift a little bit off to the north, but really you have this surface boundary that extends from west-southwest to east-northeast. And look at this subtle surface low here at 16Z, located over northwestern Iowa. And this is a very subtle surface perturbation, but I think that this surface low, as it propagates along that surface boundary towards southern Minnesota by afternoon, could be enough to back those surface winds. At least that's what the RAP is starting to hint at out through 2021Z. It's also what the HRRR, the latest runs of the HRRR, are starting to show. But the 3-kilometer NAM kind of does try to hold this little surface low back over southwestern Iowa, but still keeps those surface winds relatively veered out of the west-southwest. Here you can see a little bit of backing, though, out ahead of that subtle surface low by 19Z. Notice those southerlies across central Iowa into northern Iowa there at about 10 to 15 knots. And these due southerly winds would certainly create wind shear that is favorable for tornadoes to move off that surface front if surface-based supercells can form out ahead of this surface trough. So notice this subtle surface low that's propagating along that boundary into south-central Minnesota. Winds just ahead of it are out of the due south. A little bit further north and you get these weird westerlies out ahead of that low. But really, if this low, if the timing were a little bit slower with that, then I would think that the tornado threat would be more substantial. But still, even by 21Z here, 4 p.m. Central Time, you can see these due southerly winds in place across far north-central Iowa, extending into far southeastern Minnesota there. That's where that prime spot is going to be for tornado potential. You can see these dew points. Even the 3-kilometer NAM is mixing these dew points out into the mid to upper 60s out here across north-central Iowa. That's definitely a negative factor as well. And the 3-kilometer NAM isn't known for its dry bias like the HRRR is. And you have a little bit of moisture pooling across southern Minnesota along that surface boundary, mixing out mostly, though, across northern Iowa there. Still, though, you get some upper 60s dew points in place there. And even if there's not a tornado threat, look at this influx of moisture into central Iowa. There's going to be explosive development of a line of storms, a squall line here along this surface trough, along this frontal boundary here. And that's likely going to extend all the way back into western Iowa. But look at this deeper moisture in place across central and eastern Iowa that is going to be more than sufficient to fuel that MCS as it lifts off to the southeast, propagates southeast into this deeper moisture, likely turning a bit right as well. Let's look at these surface winds again and see the progression of that surface low. Last night, it looked like the 3-kilometer NAM was ejecting this subtle surface low all the way into southwestern Wisconsin by 0Z, and that would push these southerly winds into an area of enhanced convective inhibition. So we're going to have to see if this area across northeastern Iowa here, ahead of this little subtle surface low that by 0Z or 7 p.m. is located near Spencer, Iowa, just to the east of Albert Lee, Minnesota. And it looks like this far southeastern corner of Minnesota, northeastern Iowa, into southwestern Wisconsin here. Looks like it's going to be experiencing those due southerly winds that would be favorable for a tornado threat. Looking at the 0 to 1 kilometer EHI, you can see that's where a majority of these non-zero and very strongly positive 0 to 1 kilometer EHIs are located. Looking at the 0 to 1 kilometer storm relative felicity ahead of that subtle surface low as well on the new 12Z NAM. You can see also here across northeastern Iowa, southeastern Minnesota. That's where that zone is going to be favorable for tornadoes, but you're also going to see explosive severe weather development by later in the evening, extending down this frontal boundary, and that could impact the Des Moines area as well. But notice how the wind shear, the stronger low-level wind shear, ejects as that surface low ejects. And that's because of those relatively back surface winds out ahead of it. It's beneath a relatively strong low-level jet as well, 30 to 40 knots there, nosing into northeastern Iowa. So the 3-kilometer NAM is definitely showing this northeastern Iowa target. It's showing that surface low ejecting, but leaving enough space here for tornado potential across northeastern Iowa. A lot of it depends on that convective inhibition as well. And you can see a little bit less cape here also across northeastern Iowa where that strongest low-level wind shear is located. And that's because this subtle surface low ejects and then it catches the convective inhibition that's in place across northeastern Iowa. So really the question is, can this convective inhibition be overcome? Notice how this convective inhibition is on the order of minus 150 to minus 200. That's simply going to be too stout for that capping inversion to be broken. Possibly across far southeastern Minnesota, though, there are some holes being indicated in that cap out ahead of that surface low. That area I could see there potentially being the co-location of stronger low-level shear and a tornado threat. You can see these southeasterly surface winds there, southwesterly low-level jet at about 25 knots. Decently shaped hodograph as well over the southeastern corner of Minnesota. So I think any tornado threat is going to be north of that strong capping inversion that's being indicated by the 3-kilometer NAM across northeastern Iowa here. Look at that cap, and right on the north side of that cap there is just a small sin hole there, or a hole in the convective inhibition, where I do think that there is a chance for some surface-based supercells to develop there. Rochester, keep an eye on it. Maybe near La Crosse, maybe just to the north of La Crosse, right in the northern edge of that cap. There is a potential for surface-based storm development. And then look at this cap building into southwestern Iowa. That's likely going to prevent the development of explosive severe storms all the way back toward Omaha. But just ahead of that cap, here across north central Iowa, I do expect explosive supercell development, quickly congealing into a line, though, behind this surface low. Because those surface winds veer to a more westerly direction back behind it. Notice these westerly winds here right along the boundary behind this nose of the surface low. The surface winds go westerly pretty abruptly, and that really decreases that 0 to 1 kilometer storm relative helicity out there. I saw a comment on my Twitter today that it's not the surface winds that are going to hurt this setup, but it very much is the surface winds and really the track of this ejecting surface low that's going to determine the tornado threat on the northern edge of this capping inversion. So this strong 0 to 1 kilometer storm relative helicity across northeastern Iowa looks strong. There's a big bullseye right there, but this is directly right underneath that capping inversion, and basically an impenetrable cap there across eastern Iowa into southwestern Wisconsin. If this is right, realizing though that in Iowa crazy things happen. You can get these westerly surface winds, you can get a supercell turning due right with deviant motion into those westerly surface winds, and you can still squeeze out an isolated tornado threat and a guerrilla hail threat there across northern Iowa with that sin hole. But I do think that the greatest tornado threat is going to be on the north edge of that cap, far southeastern Minnesota there. It's possible you could get initiation around 23Z, a little bit further west, but I think you're going to need to get in this environment of a stronger 0 to 1 kilometer helicity there in far southeastern Minnesota. But notice just north of that cap, the 0 to 1 kilometer shear really tails off up there across that southeastern corner of Minnesota, and most of the strongest non-zero storm relative helicity is co-located with that cap. There is also an enhanced risk tomorrow across portions of Ohio. Looks like a linear QLCS type of a configuration. Maybe the big D word could be thrown out, derecho, but it does look like a long-lived squall line is going to continue through Indiana, eventually into Ohio, and there could be some favorable shear to get some tornadoes embedded within that line across western Ohio there. Let's take a look at the dreaded HRRR really quick and see if it also does the same thing. And it seems to have a similar evolution with the wind shear. Ejecting here across northeastern Iowa into southeastern Minnesota, right ahead of that surface low, just where you get a little bit of some back surface winds. Notice these back surface winds ahead of this lobe. Looks like the lobe is just a little bit faster in the HRRR, punching into west central Wisconsin by this time and pushing that into an area of very strong convective inhibition. But there still is this narrow swath here in the vicinity of the leading edge of that surface low, where you might be able to squeeze out sufficiently back surface winds there across the southeastern corner of Minnesota, northeastern Iowa, but then tailing back down that surface trough, that boundary, that cold front there. Notice how these surface winds veer to a more westerly direction. That's largely unfavorable for tornadic supercells. And we could look at a hodograph there in the far northeastern corner of Iowa. It does look like that cap can be broken there in that northeastern corner of Iowa, even according to the HRRR with its dry bias, 88/68 there. Decent hodograph shape. Quite a big kink there above 3 kilometers. But if you could really get a deviant motion, especially a more of a due southeasterly motion instead of this due east or east southeasterly motion, you can squeeze out a lot more shear out of that. And definitely a stout elevated mix layer as well. Some very warm 700 millibar temperatures there, well above 10 degrees C. Definitely could be an issue impeding convective initiation across northeastern Iowa. But these surface winds here in the vicinity of this low, this kind of leading subtle surface low here, that's where you're going to get sufficient wind shear for a potential tornado threat if you can get surface-based storms to develop. And it could happen right along the northern edge of that cap, far northeastern Iowa, southeastern corner of Minnesota, beneath a west-southwesterly low-level jet at about 30 to 35 knots as well. Let's take a look and see real quick if we do convect. See how bad that dry bias is. Usually the HRRR isn't as dry further east over portions like the Corn Belt, the Great Plains, the Mid-South, but in the high plains, it definitely overmixes those dew points. You can see then this convective inhibition across the northeastern corner of Iowa into southeastern Minnesota, over Wisconsin, kind of a dry pocket there across that. So if that surface low ejects too fast along that boundary, it'll veer out all these winds in its wake. So despite this deeper moisture, that's going to lead to more west-southwesterly surface winds across north-central Iowa, northwestern Iowa, south-central Minnesota. And then along the leading edge of that surface trough, along that surface low where you do have those more back surface winds, it looks like that favorable shear is going to run into an area of increasing SIN. But there definitely is a small window here where this deeper moisture is located, where that surface low may eject. You can see these surface winds there already to the west edge of that cap. West-southwesterly surface winds. So you're going to need a hardcore right mover to squeeze out a lot of wind shear. You can see though that with that photograph just below my head, there's still some non-zero storm relative felicity there in the 0 to 1 kilometer layer. You've got about 85 storm relative felicity, 0 to 3 kilometer, a little greater, closer to 200 SRH there. A ton of CAPE, about 5,000 CAPE out there. A lot of 0 to 3 kilometer CAPE, so you're likely going to have explosive development of very large hail producing storms. You can see these strong winds in the mid-levels of the atmosphere, near the location of the greatest CAPE as well. A lot of bulk shear out here, greater than 30 knots of bulk shear with these 15-knot west-southwesterly surface winds beneath a 50-knot westerly mid-level jet. Very thick CAPE up there too. So if you can get any semi-discrete supercell storms across that environment in north-central Iowa, I do think that the tornado threat is not very favorable up there. But I do think that there is a threat of guerrilla hail. And finally, you get the HRRR is really dry. So realizing that it does have a dry bias, tends to under-convect this season, mainly in the high plains, not as much out here in the Corn Belt. But it basically keeps this favorable wind shear capped. There is a lot of convective inhibition out there, northeastern Iowa, southeastern Minnesota there, southwestern Wisconsin. But I do think that there's going to be explosive development by about 7 or 8 p.m. back here across northern Iowa. Rapid development of an MCS type of an event with significant severe weather. I think by this time you're likely going to have a full-blown MCS here across northern Iowa. But a lot of those veered surface winds at the low levels is going to mitigate that tornado threat across this region. But the severe wind and hail threat is likely going to still be pretty substantial. And this will likely connect here, maybe a couple different clusters, but I do foresee the development of a big-time MCS with a widespread wind and hail threat across northern, northeastern Iowa, eventually pushing into southern Wisconsin there overnight. Closer to midnight, could start threatening the Madison area there. This thing's just going to slowly sag south toward that deeper moisture. There's that blob of moisture here, streaming up to the Mississippi River Valley, really tailing off with an eastward extent. But eventually this MCS is still going to be cranking here within that deep moisture. Eventually, though, it's going to outrun that deep moisture after midnight. And that will allow that MCS to die. And then we set the stage for Friday. That enhanced risk across Ohio, Indiana. Looks like a very linear type of an event moving in across that area, across the southern Great Lakes, central Indiana, really into western Ohio. But there's quite a bit of dry air there that's going to prevent a massive long-lived MCS or a derecho from punching into that area. But I do think we're going to get the development of multiple rounds of MCSs. Look at all this moisture by the 3-kilometer NAM in place for that MCS to thrive, though. At least on its backward edge. And it does look like the Chicago area by early morning hours. Could see a squall line with some severe thunderstorm warnings moving in. Can see a lot of stable air there that this thing is moving into, though, moving into that drier air. The back edge of this MCS could be longer lived as there's deeper moisture here across western Illinois into eastern Iowa. And it does keep going despite a lot of those that drier air out ahead of it. That MCS continues to crank according to the 3-kilometer NAM there. More of a windbag event across northeastern Indiana, southeastern Michigan. And this thing just keeps back building into the deeper moisture there as the moisture advects northeastward towards central Indiana. Definitely looks like a big squall line, complex of storms here, sliding off to the southeast into west central Ohio, into central Indiana as well. Could be some embedded circulations within that squall line, but you can see these westerly winds in excess of 30 knots, and as this squall line sags south, that's going to force these individual updrafts to move in a more southeasterly direction, squeezing out more storm relative helicity in the lowest kilometer than if these were individual discrete cells sliding more of a west to east storm motion. So that should lead to embedded tornadoes within this QLCS boundary here across west central Ohio into central Indiana. See a decent moisture shear pipe here feeding the western edge of that squall line as well. Even though the SPC has a 5% tornado area here across central Ohio, west central Ohio, I just think that's mainly for circulations embedded within that line. Similar evolution here depicted by the HRRR, but less of a monster squall line. Looks like as depicted by the HRRR. More discrete storm development. I don't buy this out here. I think that this is going to be does have greater moisture here reaching in at the last second, but I think this is going to be more of a squall line that keeps sagging south and continues to back build into these deeper moisture valleys across central Indiana. That's probably why the SPC has that 5% out there, because the HRRR came in with a discrete mode and a little bit more backed surface winds out here. But I tend to believe the 3-kilometer NAM. I think you're going to see more of a squall line sagging south into central Ohio, into central Indiana. Probably this will all be interconnected, but there's a chance that on the western edge of this complex of storms, it could leave behind an outflow boundary. It could cook during the day, and then you could get the development of some discrete supercells along the western edge of that boundary, extending back into central Indiana, west central Ohio. Here you can see the arrival of this instability axis from the west. This is at 0Z tomorrow. A lot of Cape here punching in from west to east. A big nose of Cape in excess of 4,000. Discrete supercells developing on that nose of Cape according to the HRRR. But then you get the likely more accurate 3-kilometer NAM showing a big squall line continuing to back build into that deeper moisture streaming in from the west-southwest. So I think that if there is a tornado threat, it's going to be greatest embedded within this line. If the line can propagate southeast and then force individual updrafts to attain a more of a due southerly direction to turn into those westerly surface winds, then I think that there is a decent chance of a tornado threat with those storms embedded within the line. But this sin hole right here, is going to be a problem across northeastern Iowa into southeastern Minnesota. But there is a little nose of a decent surface-based cape here pooling across southeastern Minnesota later on this afternoon. That's at 0Z. So I do think if there is a chance of a tornado anywhere, and it could even be a significant one if these thermodynamics verify here just in the north side of that cap across southeastern Minnesota. That's a pretty favorable hodograph right there. And that's near Rochester. You've got your 1 kilometer wind relatively backed out of the south-southwest. Surface wind due southeast and relatively weak, just on the leading edge of that subtle surface low, nosing in there. Plenty of 3 kilometer cape, minimal cap, and then your very strong 4, 5, 6 kilometer winds in excess of 50 knots to generate more than sufficient bulk shear for potential of some supercell storms out there. But according to this 3 kilometer NAM sounding, you've got storm relative felicity in the lowest kilometer in excess of 200. You've got pushing 350 there, 0 to 3 kilometer storm relative felicity. That storm relative felicity is proportional to the area within this hodograph curve. Plenty of area there between that storm motion vector and the shear vectors that comprise that hodograph curve up there above it. Plenty of deep layer bulk shear, mid-level shear. Look at that 50 to 60 knot jet poking in there. So there's a very narrow corridor, I think, across southeastern Minnesota where there could be a tornado threat just ahead of that surface low. And it does, even a 3 kilometer NAM tries to convect this region there. It's questionable as to whether you can get a surface-based supercell within that favorable environment north of the nuclear cap in place across northeastern Iowa. But it does try to build some surface. It looks like some convection there into southeastern Minnesota, far northeastern Iowa, banking up against that cap by about 7 to 8 p.m. So I do think that there is a window for a tornado threat here across southeastern Minnesota before this quickly congeals into a line. And many of the models are not convecting further west. And that's one thing that happens is even when all the variables appear favorable, anticyclonic flow aloft leads to gentle sinking motion, which doesn't help. If you have cyclonic curvature to the upper level flow, then there's a chance that you can break these nuclear caps and squeeze out a lot more. Well, let me show you what I mean by that anticyclonic curvature. So see this general anticyclonic curvature here. Basically you're curling clockwise with the mid and upper level flow. That will lead to gentle subsidence through a deep layer. The opposite's true when you get cyclonic curvature to the mid and upper level flow, and that punches in, it leads to large scale lift, and that can help to break some of these caps. It can help to increase lift available to these storms. It can help to strengthen surface boundaries as well. But you get these anticyclonic curvature aloft, a lot of times the surface boundaries are weakening fronts. A lot of times they have a little pressure trough out ahead of them, and it causes winds to veer immediately along that boundary. But this is a subtly ejecting surface low, so there is a chance across far southeastern Minnesota, just in the northern edge of that cap. I do think that there is a chance of a tornado or two here. You can see these due southerly winds. You've got a very strong cap, though, across northeastern Iowa, and it's going to be right on the northern edge of that cap, far southeastern Minnesota, where I do think that there is a better chance of severe weather there. And here is that enhanced risk. I guess expecting a rapid initiation along that surface trough all the way into northwestern Iowa. But an enhanced risk is definitely strong for these model trends, that's for sure. That's a big time forecast there. And we do have the latest wrap out here as well. And monitor the progress of the ejection of that surface trough. see where it is by 21Z. Uh-oh. So yeah, that is not as favorable as the 3-kilometer NAM here. Notice this nose of instability streaming up, and look at how capped it is across southeastern Minnesota, even by 4 p.m. And you really don't see that surface low, as it doesn't have as much identity in the wrap, which is usually a pretty good model out here in Iowa. There it is. It doesn't have as much of an identity in the wind field. And this is the reason why I thought this was kind of a not as favorable of a tornado setup as maybe we thought. This subtle surface low here ejects relatively rapidly off to the northeast, and it catches up with the convective inhibition. So even though it does kind of force favorable wind shear there over far southeastern Minnesota to northeastern Iowa, there's a ton of convective inhibition down here, a lot of dry air. That instability axis kind of comes over top that dry air from southwest to northeast, tries to pool along this surface boundary, but it's a weakening surface boundary beneath anticyclonic flow aloft. You get a lot of veering, a lot of westerly surface winds just immediately ahead of that boundary, and that is definitely a recipe for the development of a squall line, congealing storms, and maybe not even that if you have this really strong cap building in from southwest to northeast. It may be that MCS slides from southeastern Minnesota, forms here in central Wisconsin, and then slides down toward the Madison area by the late night hours, midnight, early morning hours tomorrow, eventually making it down towards Chicago as well. But not the most favorable setup in the world here. That is for sure. We can look really quickly at these tornado threats. I still have the big-time hail threat covering northern Iowa here, far southern Minnesota, extending all the way to the Mississippi River. Decent wind threat, and this tornado threat is definitely high. We'll have to see what happens. There's most of the models are showing a nuclear cap across northeastern Iowa, but there is a small zone here across far southeastern Minnesota, even into La Crosse area, where I do think that there is a chance of a surface-based supercell or two, in an environment that has wind shear favorable for a tornado or two as well. So thank you everybody for joining me for this live briefing on Iowa today. I'm going to be going live as well later on this evening as this severe weather event is unfolding. We'll break it down in real time, analyze the environments that are going on, analyze radar data using the Radar Omega app, and we will be sure to dominate this storm, everybody. But be safe. Stay tuned to those watches and warnings. I do wish I could be out here storm chasing in the field, but I just woke up this morning and didn't quite have what it takes to get on a plane. And the rental car deficiency out there is a big deal, but it does look like you could basically reserve a rental car for like a week, get in that rental car, probably return it a little bit earlier, maybe not pay as much, but they'd probably lock you in and make you pay that much, if I had to guess. There were plenty of rental cars available in La Crosse as well. But just the couple of the negatives with this setup, with that anticyclonic curvature aloft, the rapidly ejecting surface low, there is a lot of CAPE and a lot of gorilla hail. So if I was within range of this, I certainly would be chasing it. But I think that I'm better served doing a live briefing as this setup unfolds. Thank you everybody for joining me for this morning weather report. Never stop chasing.